Okay, we're looking at equations of lines here, or linear graphs you may have seen them as. Now, we've got 5 lines here, and they're all y equals something. So if I'm going to do a general one, okay, I'm going to do y equals, so that's the first thing. Now, if I look at them in 2 different groups, these 3 here, the blue, the orange, and the green are all parallel, all right? And this yellow and this pink one, they're also parallel. So what can we see in these 3 equations is the same? Well, the same bit is the 2x. So the number next to x, all right, is the same. So I'm going to call that number m, okay? And you may have seen mx somewhere in your textbook, revision guide, where have you, all right? And the m here is -2. Now, they all have another number tacked on the end, and that I'm going to call c. So I'm going to add on another number, so plus c at the end. Now, can we work out where these numbers come from? So we've got 2x, 2x, and 2x. We've got -2, -2 here. So if I look at these 3 initially, they are all parallel. That means their slope is the same. And when we look at how steep a line is, in maths, we use the word gradient. So gradient, as you may have seen in a previous video, is done by the rise over the run. So if I can look here, so this is going to be rise over run. And if I just look at the blue line, can I work out and see if my rise over run agrees with this 2 here? So it cuts here at -1 and it cuts here at 2. So from 0, I've got my triangle here. It rises by 2 and goes along from -1 up to 0 by 1. So there you go. So the rise over the run is 2 for that one, and I've got 2x, but I've got 2 there. So if this is parallel, let's have a look. So I've got rise over run again. Now this is a little bit trickier because I've got the rise being 1 here and the run being a half. So how many halves go into 1? Well, 2 halves make 1. Excellent. So I've not got 2 there, I've got 1 there. So my gradient, this number in front of x has got to be the gradient. So the m is the gradient. Now, if I have a look down here at the pink one, all right, if I've got my rise over run here, so my rise, it goes down 4 from 0, goes down 4, and it goes from -2 to 0 divided by 2. -4 divided by 2 is -2. Fantastic. I've got -2 here. So I've now shown that the rise over the run for these is 2, so the gradient is 2, and for these is -2. Now the last thing we have to look at is this number on its own. Okay, the c, the plus c. So where is that coming from? Now, if I look at the blue line, it's +2. And on here, my line cuts the y-axis at 2. Now, that gives me a bit of a clue, but can I test that? On my orange line, I've got +1 here. Does it cut the y-axis at +1? It does. Fantastic. And just as a check, I'll do the third one here. -2 on the green line. Does it cut at -2? Indeed, it does. So it's where it cuts the y-axis. So we've got what's known as the y-intercept here, and I'm going to use the other 2 lines just to check that. I've got -2 here. Does the yellow line cut at -2? Indeed it does. And I've got -4 here. Does the pink line cut at -4? Yes, it does. Now, bear in mind, lots of common mistakes is working out where it cuts the x-axis. That is totally irrelevant. It doesn't really matter where it cuts the x-axis as far as the equation is concerned. It's only where it cuts the y-axis, and the number next to x is the gradient. The rise over the run, all right, is the gradient. So when you're working out the equation of a graph, it's y equals the m is the gradient, rise over run, times x plus wherever the graph hits the y-axis or crosses the y-axis.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.